Hello everyone and welcome. In this lecture we will do more examples on how to find the inverse of a matrix. In the last video we did some examples on how to find the inverse of a 2 by 2 matrix and also 3 by 3 matrix and how to compute the determinant for 4 by 4 matrix. And now we will do another 4 by 4 matrix. So we have this matrix A, and to get its inverse we need first to check if its determinant is different from 0. So if that of A is different from 0, and then compute the cofactor matrix C, and then compute the adjoint matrix of A. So let's start by computing the determinant of A and check if it is different from 0. So to compute the determinant of A, we need to compute the minor and the cofactor for each entry. Let's start by this element here, or this entry here, A11. So its minor will be M11, which is equals. So we will delete this row with this column and take this remaining matrix. So it will be 1 0 0, 2 minus 2 and 0, and here 2 1 1. So as we have here this row, we can just this row with these 2 0 0, so we can delete this row with this column, and the determinant of this matrix, or this determinant, will be just the determinant of this one here. So it will be equals this one, because here also we have 0. So let's compute it normally. So we'll write these two columns here, 1 0 0, 2 minus 2 0, and the determinant will be equals. So it will be the product of this element here and this element, these entries here, the main diagonal, plus the product of this element plus the product of this element. So it will be 1 times minus 2 times 1, which is minus 2. These 2 will be 2 times 1 times 0 is 0, and this 2 times 0 is 0. So it will be minus 2. This minus the product, or the sum of the product of this element here, so this element, plus this product of this element, plus the product of these three elements. All of this will be 0 because we have here 0 and here 0 and here 0, so it will be 0. That equals minus 2. And to compute M12, which is this element here, this 0 here, so this will delete this row with this column. So the remaining matrix will be 3 1 2, and 2 minus 2 0, and 2 1 1. We'll write these two columns here, 3 1 2, 2 minus 2 0, which is equals, product of this element is 3 minus 2 times 1, so this element here with this element here with this matrix here. So it is 3 minus 2 is minus 6, plus 2 times 1 times 2, which is plus 4, plus 2 times 1, this is 0, so this will be 0. This minus product of this element here with this element here. So this 2 minus 2 times 2, which is minus 8, and here is 3 times 1 times 0 is 0, and here is 2 times 1 times 1, which is 2, so it's plus 2. This is here minus 6 plus 4 is minus 2, and here is plus 6. Here minus 8 plus 2 is minus 6, times this here minus is plus 6, minus 2 is 4. And M13 is equals, so this element here, this element here 0, so we'll write this one with this one, and all remaining will be 3 1 2 1 0 0 and 2 1 1. This is equals, here we'll write these two columns, so for equals put here 3 1 2 and 1 0 0. This is equals this element here is 0, this is 0, and this element and this element here, so this is 0 because we have here 0, and this also is 0, 2 times 1 times 0, so we have just this one here, so 1 times 1 times 2, which is 2, minus the element here, so these are 0 and these are also 0, and we have here 1 times 1 times 1, which is 1, so 2 minus 1, which is 1, and m 4, which is equals, here we will write this element here, is the minor of this element here, so the remaining matrix will be 3 1 2 1 0 0 2 minus 2 0, which is all write these two columns here, so 3 1 2 1 0 0, so the product of these elements plus the product of these ones plus the product of these ones, so this element here have zeros here, 0 here and 0 here, so we'll get this element minus 2 times 2 is minus 4, and the element here have also 0, and this one also have 0, and this one also have 0, so all of them are 0, so we'll get minus 4. Now as we get the minors of all these elements here, we can get the determinant. So to get the determinant we need to compute the factors, so here we have C11, let me write them here, C11, which is equals 1 plus 1 is 1, so it will be minus 1, so 1 plus 1 is 2, minus 1 square, because 1 plus 1, m11, which is equals, here minus 1 square is 1, and here we have minus 2 as, so it is minus 2, and C12 is equals minus 1 power of 3, because here 1 plus 2 is power of 3, m12, which is equals, here minus 1 3 is minus 1, and here m12, so m12 here is 4, it will be minus 4 because minus here and 4 here m12, and C13 is equals minus 1 power 1 plus 3 is 4, so this will be 1, m13, this 1 and m13 is 1, so this will be equals 1, and C14, which is equals minus 1 power 5, so it will be minus 1, m14, which is equals minus 1 times minus 4, which is plus 4, so it is plus 4. So the determinant of A, let me write this space here, so the determinant of A will be that A equals A11 C1, A11 here is 1, let me write this, so it will be 1, this one here, times C11 is minus 2, times minus 2, plus 0 times minus 4 is 0, plus this 0 also times 1 is 0, so we'll get minus 1 times 4, which is minus 1, this minus 1 here times 4, so the determinant will be equals minus 2, here minus 1 times 4, which is minus 4, which is equals minus 6, so it is different from 0, and then A is invertible, So now we check that A is invertible because determinant of A is different from 0. We need to compute the cofactor matrix and then the adjoint matrix to get the inverse matrix of A. So we will compute the minors of all these elements and then get their cofactors, and from there we'll get the cofactor matrix and the adjoint matrix. So let's start with this row here. We will need to erase this space here to compute the minor for the second row. So we will get the minors of the second row here, 2, 1, which is this element here 0, so which is equals, we will erase this row with this column. So it will be, this is the determinant, so 0, 0, 0, 0, so this is 0 because all are 0, so 0, minus 2, 0, minus 1, 1, 1. So this is equals 0 because we have here a row of zeros. And so let me erase this to be clear. So 2, 2, which is for this element 1 here, so we will erase this row with this, or this column with this row. So the remaining matrix will be the determinant of 1, 1, 2, and 0, minus 2, 0, and minus 1, 1, 1. So we will write these two columns here, 1, 1, 2, and 0, minus 2, and 0. So this determinant will be the sum of these product of these elements plus these ones plus this one. So it will be equals here minus 2, and here 0, and here 0. So minus this element here, and this element here, and this element here. These are zeros because we have here 0 and here 0. So these 2, minus 2 and 2 will be minus because we have here minus, and the product here will be 2 times minus 2 times 2, which is, this must be minus 1. This is 2 times minus 2 times this minus 1 here. This is minus 1. So it will be 2 minus 2 is, or minus 1 times minus 2 is 2 times 4 times 2 is 4, which is equals minus 2 minus 4 is minus 6. And 2, 3, which is the element here 2. So let me write this. These 2 here with this row. So it will be equals 1, 1, 2. So this is a bar. And here 0, 0, 0. So this determinant is 0 because you have 0 here. And minus 1, 2, and 1. So this is equals 0 because here we have column of 0. And 2, 4, which is equals also so for this element, let me erase it. So this element here with this, or this column with this row, so it will be here 1, 1, 2, and 0, 0. So as we have here zeros, so it will be equals 1, 1, 2, 0, 0, 0, 0, minus 2, 0, which is equals 0. And when we compute here the determinant, we will get it because the determinant of A is equals here just this element here 1. So I will read this to be clear. This element 1 times here C1, C2, 2 is equals M2, 2 because 2 plus 2 is minus 1 power 4, which is 1. So it will be M2, 1. This is minus 6. So 1 times minus 6 is minus 6. So it is verified also here. This can help us to be sure that we didn't make any mistake. So now we'll write here the cofactors for these entries. So they will be C21 and C22 and C23 and C24. So this is equals 0 because the M1 is 0, M1 and 21 is 0, and this one will be minus 6 because 2 plus 2 is 1, so it will be minus 1 power 4 is minus 6, and the two ones are 0 also. So we will need the cofactors, we won't erase them, and we will erase this part here to compute the cofactor or the minors for this row here. So now we will compute the minors for this row. So we'll start by M31, which is the element here, this one here. So we will array this row with this column, and we will get the remaining matrix will be 0, 1, 0, and 0, 2, 0, 0, 2, 0, and minus 1, 2, 1, minus 1, 2, 1. So when we look to these two columns here, this column and this one, we see that this column is equals 2 times this column. So that means this matrix or this determinant is equals 0. And also the two rows here, 0, 0, minus 1 and 0, 0, 1. So here is minus 1 R1 when we call this row R1. So this also are these two rows also are proportional, and their determinant will be equals 0. And M32 for this element here, let me write this. For this element, this 0 here, we'll write this column, which is equals 132 and 0, 2, 0, and minus 1, 2, 1, 2, 1. So we'll write these two rows here, 1, 3, 2, 0, 2, 0, and we'll take this element here with these ones here, so it will be equals 2, here 0, and here 0, so there are zeros, minus, here minus 1 times 2 times 2 is minus 4, and here 1 times 2 is 0, so and here also is 0 because here 0, so these are 0, and here will be minus is minus 4, so minus times minus 4 is plus 4, it will be 2 plus 4 is 6. And M33, which is this element here, minus 2, so let me write this here, so it is equals the remaining matrix, so here minus 2, so 1, 3, 2, 1, 3, 2, and 0, 1, 0, 0, 1, 0, and minus 2, minus 1, 2, 1. So we'll write these two columns here, 1, 3, 2, and 0, 1, 0, 0, 1, 0. So this will be equals the product of this element are 1s, and 0 times 0 is 0, and here we have also zeros, so they are 0, minus product of this element here, minus 1 times 2 is minus 2, and here are 0 and here are 0, so this will be equals minus times minus is plus, so it will be 1 plus 2 is 3, and M34, which is equals, so for this element here 1 equals this with this, so the remaining matrix will be 1, 3, 4, 1, 3, 2, and 0, 1, 0, and 0, 2, 0, 0, 2, 0. So this is equals, here we have these two rows here are proportional, so 0, 1, 0, and 0, 2, 0 are proportional, and these also two rows, these two columns are proportional, and these two rows here are proportional, so this row the first row with the third row are proportional, and the second column with this second column with the third column are proportional also, so their determinant is equals 0. And to compute the determinant of this matrix is equals 0. And to compute the cofactors will be C31, which is equals here 0, so it will be 0, and C32, which is equals, here we have 6, so here 2 is 5, so it will be minus 1. Power of 5 is minus 1, and here 6 is going to be minus 6. And M33 here is 3, so but 3 plus 3 is 6, so it will be minus 1 power 6, which is equals 1, so it will be 3. So C33 is equals 3. And C34 is equals 0 because M34 is equals 0. So C34 is equals 0. And determinant of A, to check that our calculation is correct, will be equals determinant of A equals, let me erase this to be clear. So it will be 1 times 0 is 0, and 0 times minus 6 is 0, and minus 2 times 3 is minus 6, and 1 times 0 is 0, so t is equals minus 6, and it is the correct determinant. So our computation or our calculation is correct. And we will now compute the minors for this, the last row here, and we will need this space, so we'll erase it. So that the M41, which is equals for these two here, so we'll write this row with this column, and this will be 0, 1, 0, 0, 2, minus 2, and minus 1, 2, 1. So there is no proportional here, I think, no proportional, so we'll write these two columns here, 0, 1, 0, 0, 2, minus 2. So this is equals, the product of these ones are 0 because here 0, and these ones are 0 also, and this one will be minus 1 times minus 2 is 2, and this minus product of this element minus 2 times here is 0, so, and here also is 0, and here is 0, so these are 0, so this is equals 2. And M42, so for these elements, for this 0 here, so it will be, we'll write this row with this column, and this will be equals 1, 3, 1, 0, 2, minus 2, and 1, 2, 1. We'll write these two columns here, 1, 3, 1, 0, 2, minus 2. This will be equals, product of this element is 2, these are 0, and this 3 minus times minus 2 is minus 6, minus product of this element, 1 times 2 is 2, and 1 times 2 times minus 2 is minus 4, and here are 0, so these are 0. Here will be 2 minus 4 is minus 2 plus, it will be plus 2, and minus 6 here, so this will be equals minus 2. And then M43 is equals, here the element here 0, so the remaining will be 1, 3, 1, and 0, 1, 0, and minus 1, 2, 1, minus 1, 2, 1. So we need to write these two columns here, 1, 3, 1, 0, 1, 0. This will be equals, product of this element is 1, and these are 0 and these are 0, so minus here minus 1 times 1 1, and here is 0 because here 0 and these are 0 also, so minus 1, this will be minus 1 minus here, so will be plus 1, which is equals 2. And the last one is m44, c is equals, so let's read this space here. We know that m41 is equals 1, so we'll write this space to compute m44 here. So m41 is equals 2, and m44, which is equals, so this element 1 here, let me write this. So this element here, the remaining matrix will be 1 3 1 and 0 1 0 and 0 2 minus 2, and write these two columns here 1 3 1 0 1 0. So this product will be equals minus 2, and z is 0 and here are 0, and this minus product of these are 0 and here is 0 and also is 0, so this is 0 and we'll get minus 2. So the cofactors will be C41, which is here will be minus M41 because here sum is 5, so it will be minus 2, and C42 is equals, here will be same as M42, so it will be minus 2 also, and C43, here the sum is 7, so it will be minus M43, which is 2, so it's minus 2, and C44, here the sum is 8, so it will be the same as M44, which is minus 2, so this is minus 2. And to check if the computation or the calculation is correct, we need to compute the determinant. So let me write this. So let me write it here. Determinant of A is equals 2 times minus 2 is minus 4, and here 0 and here also 0, so there will be zeros, and 1 times minus 2 is minus 2, so this is equals minus 6, and that means that our calculation is correct. Now we'll need to write the cofactor matrix C, so we'll write this space here. So the matrix C will be equals, it will be 4 by 4 matrix, so C11 is minus 2, C12 is minus 4, and C13 is 1, and C14 is 4, and C21 is 0, and C22 is minus 6, and C23 is 0, C24 is 0, and C31 is 0, C32 is minus 6, C33 is 3, C34 is 0, and C41 is minus 2. All of them are minus 2, so minus 2 here, and minus 2 here, and minus 2 here. So this is the cofactor matrix. And the adjoint matrix is the transpose of this matrix C, so adjoint of A is equals C transpose. So the transpose of this matrix is, this row here will be the first column, this first row here will be the first column, so it will be minus 2, minus 4, 1, 4, and 0, minus 6, 0, 0, and this row here, which is 0, minus 6, 3, 0, and this row here will be the last column here, minus 2, minus 2, minus 2, minus 2. So now we can compute the inverse matrix A minus 1, which is equals 1 over determinant of A times the adjoint matrix of A. So we'll erase this space here because we don't need the cofactors as we get the adjoint matrix here. So A minus 1 will be equals 1 over determinant of A is minus 6, so 1 over minus 6 times this matrix adjoint here, so it will be minus 2, 0, 0, minus 2, minus 4, minus 6, minus 6, minus 2, 1, 0, 3, minus 2, and 4, 0, 0, minus 2. Now this will be equals minus 2 over minus 6 is 1/3, so 1 over 3, and here will be zeros, and minus 2 over minus 6 is 1/3 also, and minus 4 over minus 6 is 2 over 3, and minus 6 over minus 6 is 1, minus 6 over minus 6 is 1, minus 2 over minus 6 is 1/3 also, and here is minus 1 over 6, here is 0, and 3 over minus 6 is minus 1/2, and minus 2 over minus 6 is 1/3 also, and the last row here it is 4 is minus, so minus 2 over 3, and here are 2 zeros, and here is 1 over 3. So this is the inverse matrix of A, and when we multiply this matrix A here by this matrix A minus 1, the result will be A minus 1 will be the identity matrix, so it will be I4.